Okay, so hello. So last class we have seen regarding the planar column manipulator, means how the atoms work. Okay, the design part. Now we will see with one example how the kinematic part we have seen, how we are going to give the joint portions and also the motion of the system. Now we will see how we are going to deal with the dynamics of the system. Means if we provide some information and we will write some program, so how it is going to be taken care, like some modeling we are going to do. So for that we have to first we'll go with the our, or we can make some new problem. Suppose model 2. So today it is the dynamic. So dynamic 1 we can write dynamic system 1, and then mmks normal figure. Okay. So this is our one system. Simple slider kind of mechanism we will take one example for the mechanism, and then we find whether it will work fine or not. So now I forget this to be here. Hello. Okay, so now we will see how to do this particular job. In this particular manipulator, we are going to deal with the dynamic system modeling. So in the dynamic system modeling, what is the requirement? So as we have seen in the lectures, the thing is like a dynamic of motion equation. Okay, so this is required, means we have to define the mass, Coriolis component, gravitational component, and then we have to do the modeling. So so we are going to integrate this with the atoms. Okay, means the mathematical modeling with the atoms, means where we can write the mathematical modeling, we can write a mathematical modeling in MATLAB. Okay, so how to integrate then MATLAB and these atoms, that we will see today with some example. Okay, so suppose we are going to have one slider kind mechanism. So as I told you in the last class, how we are going to make it. So same way we are going to do the analysis for that. So first one, depth, width, and length we can make it like freely we can choose. So that's why I'm just putting it as it like this. So this is your first part. Second part we are putting like a this one. Okay, and so I think it's okay. You can just put it like a smaller one. So that's why. Okay, so we are going to put it like a first this side. Okay, so that will be better, or this side like this, and the other one like here. So now two links are there. Now we are going to have one box. So I will click on the box, and again I have to change this one. So suppose it is 5, it is again 5, and it is length we can choose as per our convenience. So this is the length. Now we can just have from here to here we can move. So move command we can use it from here like this. So like this. So did you join? Did you install Adams? From where? Okay, so within 1 day you got it, na? Okay. So now you can see this particular modeling we have done. So are you able to do this one in your system? You try to do it. Then we can provide some connector. So for the first one is the joint connector, that is revolute one. So this ground and to this part, this is one revolute joint. Second revolute joint, second part and third part, and in between the location. And third revolute joint like this part and this part, and then again revolution, and then this is the slider. So this part and ground, and I will choose this way as a okay like this. Okay, so this is my complete picture of this one. Now earlier class we have seen that we have given some translation and finding the rotation, but suppose now if I will give some joint or some motion to the joint, then what will happen? So suppose I will provide a motion to the joint. So joint motion is this one. Okay, so I will give like a joint motion to this one, joint one. Okay, so joint one I have given. So this is the joint motion I have provided. Now in this joint motion, what I can write? I can give some time function or something, like suppose it is 30 into degree into time. Okay, so suppose I am writing like a in sine wave function. Okay, so 30 into suppose uh, okay, let's see, sine 30 degree into sine time. Okay, so sine time we can say sin, and we can give some 0.5 into time. Okay, so this is my sinusoidal, means it can go and come like this. Okay, so that I have to provide. Okay, so now I have given, now I can go and simulation, check the simulation here, and here if I will make it a step, 10 step, and step size is like just a 0.1. Let's run. Okay, so if I want to see like a little bit lower case, and this one is a 50 second, and if I will run, so now you can see this direct mechanism is 30 degree, means it is only rotating 30 degree into sine time. Okay, so 30 degree will rotate and sine time. Okay, so this is the function it is happening. So now if you want to see how the translation behave, okay, so simply click on the joint and see the measure. Okay, and in the measure point you can simply check which direction it is, x direction. Yes, x direction motion. So just apply this one. So you can see like 0 to 50 millimeter. Sorry, not in x direction. It is not coming in x direction. Let's see in magnitude. Yes, in magnitude it is showing. Okay. So here you can see how much distance it is passing from here, 34 point something like to like that. If I will run it, so you will find it. Okay. Suppose I will run. So it is showing like that. This particular part is, I will see. Yes, so this is the way to first define that we have seen in the earlier class also. Okay, now after this complete 50 second we have given, I think. Okay, so it will run till the 50 second. Oh, so I think I have to pause it. Okay, So this is the way to define. So you can see here in the tree, this is the tree of the system. Whatever the things you have taken, suppose you have taken body, so you can go, you can find out the different bodies are there. So even you can make it a rename. Suppose this particular part 2 is my some other name, so you can just rename it. What is your part 2? It is a crank. Okay, so I will write a crank. Okay, so new name na, here I will write crank. Okay, so okay, crank, it is done. Crank. Part 3, if I will write here, make it a rename. What is this one? Connecting rod. Yes, so I can write this one as a connecting rod. So you see here we cannot give a space, you have to provide some days. Okay, so you have to write it here, crank connecting rod. Okay, so then you can apply. Okay, so now it is changed. What is your part 4 name? What is your part 4 in this system? Slider. It is there, but in reality what we say it, piston, cylinder piston arrangement, na? Cylinder piston arrangement. Okay, so we can make it a cylinder piston. Okay, so this one I can write, and this done. So now you have your own, like whatever the systems is there, you have the written way. Now you can go to the connectors. What are the different connectors? It is there. It is simply showing joint 1, joint 2, joint 3. So better we can rename it. Okay, so joint 1 is your nothing but a revolute joint 1. Revolute 1. Okay, so this we can make it some change or all. Joint 2, it is also revolute 1. So revolute 2. Okay. Other one is the revolute 3. And the last one is the slider or translation or prismatic. Okay, so all three you can write. So I am writing here prismatic. Suppose prismatic. Okay, so now it is done. Your connector is also done. Then motion. What is this motion you have given? If you are given something in the joint, so what we called it? What is here? If you will see this picture, what this picture says, means what is the this picture related? Okay, how the piston cylinder arrangement, I mean this one used in IC engine, na? How it works in the IC engine? It's first rotating or translating? What? So external force done in which part? Slider. So slider have some forces, then it will rotate. Okay, so in that case, what is your input? Force means on the slider side. Slider movement or displacement is the input, and the output is here your crank rotation. But here what is happening? We have given a motion on the crank, and we are checking on the slider. So our input is here angular rotation. Crank is our input, and we are checking the displacement translation. Okay, so This is the thing which is happening here. Now here I can give as an input. This is my input motion. Okay, so this is, we can say, the input rotary motion. Okay. Okay, so now this is done. So now you have defined all the system, all the thing. Now we have checked one measure. So I think this measure one, that is the prismatic joint we checked. So that I will remove. We are checking the prismatic magnitude. Okay, so this is your output. Okay, so we can say this measure is nothing but the displacement of prismatic joint, that is the output. Okay, so I will write prismatic output, displacement. Okay, so this is your output now. Okay, so now you have this particular part. Now we are going to what other things are required for the dynamic modeling. For the dynamic modeling or analysis, even in the kinematic analysis, you have some input and some output. Okay, so now what is the basic things you require? Like something there should be the input and something there should be the output. But how your machine will understand, how computer will understand, or how software will understand that which one is the input or which one is the output? Okay, so basically we have to define it. Okay, we have to define what is your input and what is your output, and accordingly your system will work. Okay, so what I will do, I will go on the element. Okay, so here you can see there is a one kind of state variable. Okay, so this state variable I have to define, means it is varying. Okay, so which one is varying here? Angle is varying. Then we are getting to find out the x position. Okay, so we will define this one as a angle. Angle is your main part. Okay, so here we can go and check what is your sorry, so which part you are going to define it here. Okay, so you have taken a marker, point, design variable, measures, or anything else. Okay, so here we can see we are going to define something like a regarding like a joint. Our motion is the main parameter. Okay, so how can we define here? Is there any part you can see which is rotating? Design variables, which can be the design variables. So whether we can define parts or any other thing, or result data we have not find. Measure is only for the, we can say, the output. Measure we have done for the displacement. Okay, not for the rotary. Okay, so we can say that we can define the part. So we which part we can define? So here you can say part gauge. Now which part you are going to define? Crank is your part. Okay, so that you define and you apply and then okay. Okay, apply and then okay. So now you have a one element, that is a system element, that is the your part. So this part can have a two type of motion, in x direction and y direction, not clockwise. This part can be in a plane. So this part in the plane have the two motions in the plane, like a axis coordinate and y coordinate. Okay, so that's why this variable 3 and 4 is coming into the picture. Okay, now this is your variable. So you have defined it. Now we can go to the design like simulation. Okay. Plugins. Okay, in the plugins you can see there is some different parameters: control, vibration, durability, make autonomy. So anything you can find out, or you can apply, or you can relate it. Okay, so suppose we are going to design a dynamic modeling, means we are going to control it. Okay, basically the designing of a or modeling as a dynamic system means what? We are going to control it. That's why we are doing a dynamic modeling. Okay, so for that we have to go to the control system. Okay, so here in the control system you can export your plant. Okay, you are exporting your plant. So now in the new control plant you are doing, and you can, if you want, you can write the different name of it. Okay, suppose this is my dynamic modeling, so I am writing dyna 1. Okay, so I can write it like this. Okay, so now here you can see what is the your input signal, what is your output signal. So what is your input signal? So here you can all object, all active object, all into inactive object. Okay, so it's okay. Now I got it. Okay, before that what we will do, we can go on this particular motion which we have defined as a which one variable we defined. Okay, so we can go on this motion and modify this one. Okay, and in this particular function time, okay, we have to define the parts. Okay, so what parts we have taken it? Crank. Okay, apply. Okay, apply. Okay, okay, so now this we have to associate with the variable value. So here we can write one term, that is variable val. Variable val. Okay, and which one we have defined? That is the crank. The name was the crank. Okay, so now I will apply. Oh, what it is showing? Variable val. Rotational only, na? Velocity, not velocity. Okay, so I have to take this one. Parts, crank. What is not taken? Oh, variable val crank. Then define a crank routine. Okay, apply. Yes. I think now it is no, nothing. What is it? Crank and then give some values. Okay. Crank and or we can say simply variable value t. What is this? Just a minute. So if you get some kind of difficulty, then simply you can write here Adams view help. Okay, so directly you can write, you can find out here support page, or in the software also there is a help plugins. So there is a file, yeah, directories. So where it is? I think I got somewhere. Okay. Okay, let us see here. Okay, variable value, val in Adams view. Variable value refers to command used to access value of design variable within the functional expression, allowing you to dynamically. Okay, so yeah, that I have written, but it is not. Oh, that I have written. What is that? Design variable and then control plant export. Before that, I have taken this one. Here I have to write variable value parts. So here variable well and then crank. That is the defined. Yes, together with the no to this should become. I think some problem is there. Crank is only na we have defined. Prismatic connectors body. Okay, let's see. Hmm. Design variables. No. Okay, so I think this will be not taking care. Estimate. Okay. So I think let's see this one if it is having some information. So here the same thing is happening which we have done, but our approach should be okay. So these all are yeah. So here it is showing. So we are just that we created the same thing they have created. I think this is the very old version. But our is the good version. That's why this box is not coming. Or directly we can create a design variables. So thereafter it has a something like a okay. I forgot this one link. So I think I have given this one. I have same thing I have given. Okay, so the link I have given, but it is having some problem. I think. Let me see this one. Design variable. Let me delete it first, and then we'll start with the same parameter like this. We have to go to the design element, and in this design element we have to define the design variables or markers or any measure. Suppose measure, let's see all objects. Active objects. Okay, apply. Okay, apply. Okay, suppose I will give this one variable value, modify, or I think this part is little bit okay. So here I will give measure So I think in the student edition that one is not, that particular parameter is not taking care, because maybe there will be some limited version. So that we will see later. In case of the my, I have some other version, license version with me in different laptop, so that I will show you. So what I do, I can just let you know the other points in the this Adam software which we can take care. Okay. So now let's see. Suppose this all you are making like a 2D diagram. Whatever you are making here, 2D diagram is there. But there is also a possibility to make a 3D, three-dimension diagram. So how can we make it? What is the possibility? How can you make it a 3D diagram if you want to make it here in the atoms? What is your imagination for making it? Because it is only plane you are looking here, na? Only plane is there. We will add thickness, so okay, this will create as a 3D model. But suppose I will make a 3D mechanism. Suppose this is my body, okay. So if I will suppose there is some joint, and I will see there is a other joint. So how you will reach that particular directions? Because it is only plane. You see here, it is only plane, no? One grid. No, not variable kind of thing. It is like we are making a surface, a boundary for each. So how can we make a surface? Means how can we make a different surface on different plane? So this is one plane, second plane, third plane, fourth plane, fifth plane, sixth plane, like a cube. Okay. So how can we make these different planes here? Directly you cannot take it plane like a in other systems. What you have other dynamic modeling system, or just simple like a design modeling software, you have a plane type of one plane command. But here there is a no plane command. So there, what we can do, we can just I will show you. New database. Yes, okay. So like a 3D model, 3D model. Okay. So now here what we can do, here we can simply go to the this one that is called as the tape point. Okay. So we have to create a different point. Okay. And then we can find, and then we can create a link between that or box between that, and then we can find out a, we can say 3D structure or 3D mechanisms. Okay. So suppose what is your 3D mechanism? One example, if I will say, so a simple example of 3D mechanisms, what it can be? Not in a plane. Suppose it cover all the other planes, but it should be simple. What it can be? It, suppose this plane is there. Suppose other plane you want to take. So same 4-bar mechanism or a sliding mechanism we can use. One part would be here, other part would be the other plane. Okay. Instead of full plane, we are making the other plane. Okay. So suppose if I want to create that kind of a structure, how can I make? I can simply click on the table, point. Okay. And in this point, whenever you click, you will find a different points. Okay. Now this point which we are connecting. Okay. So now this point we can make a like a table in the form of table. Okay. Different coordinate we can do, x coordinate, y coordinate, z coordinate for that particular table. So how can we give that one? So this is called as a, once you click it, you will call it a point table. Okay. So in this point table, once you click it, you will get a point table. Okay. In this point table, you click it, you will find a point 1, point 2, point 3. So suppose this point 1 is a 1, 1, 1. Now the second point, if you want to create, you can go here and create. Okay, so suppose it is in the x direction, it is, suppose x direction it is the 10. Okay, so now you can just apply it and you can see it is created. That's sorry, Control Z. So okay, so 10 xy and z is 0. So you can just apply and see whether it is created or not. Yeah, this side. Oh, it is very 50 millimeter is the distance or net. So we can give like a 100, then only it will be visible. 100. So now you see. Okay. So similarly, you can just give the z direction. Suppose create, and one point you can give like 100, 200, and it is 100, and then apply. Now you will get the third one, but you can see if you will rotate it, you will find it is in the, you can see it is not in this plane, it is in the different plane. Yes, so that kind of things are possible. And if this is happening, if this part is happening, means you are now able to make any kind of structure even in the 3D and do the simulation or analysis. Suppose you have invented new structure or new mechanism, that's why this software is very important. Suppose you, whatever the conventional mechanism you have, but suddenly in your mind something came that it might be this also. Okay, so if you want to check it, simple, you make the model here and try to simulate, like run it using the joint and link connections. Okay, when it will run without any error. Okay, like you have some singularity issue, you have some design issue, your design is not correct, like that type error will come if your design is really not correct. Okay, so once it will come, means you have some difficulty in your design, but if it is coming, it will give you the solution. Suppose if let's check one thing, then you will find out. Suppose for your checking purpose, I will make two different design. Okay, so you will check whether it is, which one is correct or which one is not correct. Unnecessary I can make 2z. Okay, so suppose I will make one, this one width, and this one this. What happened? Yeah. So you please inform about exam. क्या हो गया इसको? Okay. Okay, so let's see to check whether the system is really work or not. Suppose I will make like this. Okay. Now if I will make it like this, and I will give all the joints, all are the revolved joint, 1, 2, 3, 4. Okay. Now I will apply some motion here. Motion. Now I will give some sinusoidal information. Okay, 30 into d into sine 0.5 into time. Okay, so this I will give, suppose, and if I will run it, like 20-second step side 0.1. Now it is running well, there is no problem. Okay, now you can see 0.001. So what kind of mechanism we call this one? Rocker. It's a rocker. Now, as you have seen in your, you can say, system, means in your mechanism, this kind of mechanism is not possible. Which one it was? There it was showing, na? It is not a mechanism, it is a structure. No. Itself, if you will draw something, then it is showing it is a structure, it is not a mechanism. In which case? Oh, okay. Degree of freedom 0 means which kind of structure you have seen, which is having 0 degree of freedom. What was the insight of it? So which one? Outside means. So suppose I will make, okay, this is your one mechanism. Okay, now we will see क्या हो गया, कौन है? So suppose okay. So suppose I will make a mechanism which is having like a so like that. Okay. Oh. This one. So now these three connection I have given. Okay. Now if I will apply some motion to this one. Now if I want to check it, okay. So it is showing that simulation operation failed, and it will show the position kinematic analysis. The model contains incompatible redundant constraint. Okay. So this kind of error you will get if your mechanism is not really, you can say, available to make it, or really it is not feasible in reality. Okay, so that time you will get it directly. So that is why this software is very important to check any, if you are working in a robotics and mechanism field, to check your each and every mechanism which is coming in your mind. Simply you can draw it here and check it. If it is not, then it will show like this here. Okay, so with this, thank you very much for today's all session, and then we will see the next session, or means the examination part only. All session is over, examination part is there only. So from 2 o'clock we have the exam. Okay, so you ask others to join our exam, and then we will see. Okay, thank you. Military आपका हाँ 3 बजे क्लास है। तो आप तो 2:45 में आओगे ना?
ठीक है,
क्योंकि उस टाइम तो हमारा एग्जाम चलता रहेगा, आ सकते हैं आप। अब तो ये सेशन खत्म हो गया पूरा ये, इसमें नहीं रिकॉर्डिंग का कुछ